Okay. In the last class, what we did, I just like to refresh your mind. In the last class, like we have a plane stress element, and it's subject to sigma x, tau xy, sigma y. Then we cut this element. You can cut any direction, right? But we cut diagonal. And then we figure out the force, not force, shear stress and normal stress at the common point, right? That we do. Then right over here, a sigma, and this is the tau. Now, you can put sigma opposite direction. You can say, sir, I like to put sigma this way, tau this way. Yes, you can do that. You can do that. But equation will be same, but only it will have some change in sign. So it don't matter. Other thing, if you look right over here, this tau, try to rotate this object along anti-clockwise direction. It's upward, right? And this one also tension, sigma x. So that's why we put it in this one like tension along this direction. This is tau. That means this one also try to rotate this body similarly like this one, anti-clockwise. Then we figure out the formula for sigma and for this tau by summation of force along x-axis is 0 and summation of force along y-axis equal to 0. Then we got two equations, right? From that two equation, we figure out value of tau and value of sigma. And you see that this angle phi, it could be any angle. It might be 10, 20, 30, 40, we don't know, right? So we just took a variable parameter. The cutting angle is, or angle of plane is phi. Then we figure out a equation. That equation is right over here. And this equation we derive it. This equation. Bottom one for tau and top one for sigma. So in this equation, you see sigma x, sigma y is the external force or external stress. You can see from outside. This one too, and it is not changing. But phi, you cannot say it is fixed. It is a variable, it is not fixed. Similarly, sine phi, but tau xy is constant. Then this equation we got for shear stress. This is the constant and this is the constant tau xy. Now, we got these two equations. This two equation is called mother equation of plane stress formula. Because from, if you know the angle phi, then you can figure out the value of sigma and tau in that plane. Okay, but question is that for which value of phi, sigma will be maximum and tau will be maximum. That we need to say. So if I like to show you, 1 second, if I go for a new share, if I share the Excel, so in that Excel, just for example, this is angle phi. Okay, PSI, I just put. Then this is sigma. Sigma, this is tau. So what you did, you just put change the angle. Say angle you put 5 degree. For example, you got sigma 20, tau you got say 67 megapascal. Okay. Then you change the value to 10. Then you got sigma say 40. And this one you got 66. Then you go 20. You got this one 80. tau, you got 0. Then increase more. Say you go 30, your sigma you are getting 70, tau getting say 35. Then you say angle change 35, you got this one 45, tau you are getting 7. Then similarly put lot of angles, say last one I'm putting 65, this one coming so 39, this one coming say 56. Okay. Let me erase this row. Okay. Similarly, you got say 70 right over here, sigma you got 56 for example, and tau you are getting -7. So from this table, what you see? You see for certain value right over here, why the sigma is coming maximum at 70. At 30-degree angle, value of phi, the sigma coming maximum. Sorry, this is 20 degree. At 20 degree, sigma coming maximum 80, and corresponding tau is coming 0. Because phi equal to 20, you just put that value in the mother equation, like this equation. You put phi equal to 20 right over here, and also bottom. Similarly, you put 30, 35, 41 the value suits. Now, so right over here, you see that 200-degree angle, sigma maximum, and tau getting 0. Similarly, you might get, for example, angle 72, you might get over here 45, this one you might get 0. So now, if we look this table carefully, it's not 9, it's so if you look carefully, then what do you see? You see for angle 20 and phi. For 20, you're getting sigma maximum. So sigma max equal to, you are getting 80. Corresponding tau is 0. Tau equal to 0. And sigma minimum, you are getting 15, but tau you are getting 0. So what do you see over here? For certain angle, you are getting shear stress 0, but sigma value coming the highest. Similarly, for certain, so this one getting for 20-degree angle, right? And this one we are getting for 72-degree angle. So this 20 phi equal to 20 and phi equal to 72. These two angle is called principal plane angle. Because if you cut the object at this plane, your normal stress coming the highest and shear stress coming 0. That means at one stress, if you cut the body at different angle, say this body, and now you are cutting, you can cut this way, you can cut along this line, you can cut along this line, any way you cut. But one stage, every time you cut, what you get? Every time you cut right over here, you get the tau. And you get the sigma for this plane, cutting along this direction. Right over, you got the tau. And sigma will walk along this direction. So for each plane, you will get 1 tau, 1 sigma. But we see that at 200-degree and 72-degree angle, if you cut, in both plane tau 0. One time you are getting maximum sigma, Other time you are getting minimum sigma. So these two angle is called principal plane angle. Normally it's a phi n, phi p. Similarly, if you look to the tau, you see on stage tau getting maximum and minimum. Say you see at 35-degree angle, we're getting tau equal to 70. 70, and at 70-degree, tau equal to -70. And this is will be also 45. And you see sigma, you are getting the same then. Tau is the same, but one tau positive, other tau negative. And both case sigma is the same. So there are two angles. That means it's 70-degree and this 30-degree is called phi s. So if I say phi s equal to is 30-degree minus 70, not 30, 35 to so this will be 35-degree, 35-degree and 70. So this is called phi s. That means this is the principal shear stress. That means at that plane, shear stress we are getting maximum. Now, you see normal plane, you got sigma maximum, tau 0. So if you only design with this criteria, your parts, you are not sure that your parts is experiencing no shear stress. But in other plane, that means somewhere in the parts expressing maximum shear. How much that shear? It's 70. 70 and minus 70. So we need to design a parts based on maximum normal stress or principal stress, and also based on shear stress. So we need to figure out the both. So that's why we need to figure out this formula, phi p and phi s. Now, these two formula we can figure out by how? Two angle. Like you can use spaceship, you can use 1 degree, 2 degree, 1.5, then increase until 9. Figure out the sigma 1, sigma 2, you can figure out from the Excel. But it will be very difficult, right? So better to figure out a formula mathematically for principal plane and for the shear plane. Then you just put all the number, you'll get the angle. You don't need to use the repeated iteration. Okay. So how we can do that? You see right over here in this mother equation, sigma and the tau is variable because sigma and tau depends on phi. If phi sense, sigma will take sense, and tau will be sense. Okay. So before that, we need to learn some definition. That what is principal stress and principal plane? What is principal plane? The cutting plane where shear stress is 0, but normal stress is maximum. That plane is called principal plane. So it's the plane in the plane stress element, plane in the plane stress element, where it's saying 1 second. Oh, I'm not able to pick up this wire. It seems like my mouse. I like to pick up the. Anyway, so you see, something wrong with my mouse. 1 second. Okay, you see it says the plane in the plane stress element where shear stress 0 and normal stress maximum or minimum. is called principal. So principal plane is a plane where shear stress and the coming zero, but normal stress coming maximum and minimum, that plane is called principal plane. And the corresponding stresses are known as principal stress. Then the maximum value of normal stress is known as major principal stress. And minimum value of normal stress is called minor principal stress. At principal plane, normal stress sigma is maximum or minimum, but shear stress is zero. Now, similarly, what is the maximum shear plane? They say the plane in the plane stress element where shear stress is maximum is known as maximum shear plane. And max shear plane tau always maximum or minimum. Okay, so sometime we put question in the exam, what do you mean by principal plane or principal stress? What is the maximum shear plane? In maximum shear plane is the plane where the shear stress value is maximum. That plane is called shear plane. And the stress in that shear plane is called maximum minimum shear stress. And what is principal plane? The plane in the plane stress element where shear stress zero and normal stress maximum or minimum is called principal plane. The corresponding stress are known as principal stress. So we need to derive a formula for principal angle. So after derivation, we'll get this formula right over here. It's saying tau. I don't know any reason my mouse is not picking up the annotation. So you see tan phi angle, this formula we need to derive. Similarly, this is the shear angle. This shear angle we need to derive. Okay. So, and after derivation, we get this formula. This two is mother formula. That means I am not able to show you live. Hold on. No, not working. Okay, so let's see how we can solve it. We can figure out the maximum principal plane and maximum shear plane mathematically by using the formula. So what I'll do, I will share one more screen. That's a MathCAD screen. Okay, did you see the
Yes, sir.
MathCAD file? You can
It's
see,
visible.
right? Okay, thank you. Let me, right now I have draw it. Okay, so you see, same free body, I just put it over here. So just refresh your mind. And right over here, you see, this is our mother equation of sigma. We need to figure out for which phi this sigma will be maximum. Because you cannot change sigma x, sigma y, tau x, because they you already applied external. So inside remain tau and phi. Tau and sigma. This tau and sigma you cannot see from outside, right? But inside, if value of tau and sigma become higher than material resistance, then what will happen? It will be cracked or fail. If tau or sigma less than the material allowable, then it will not fail. But I need a tool, scale, so I can figure out that if I load a plate like my cell phone, if I pull it this side, pull it this side, then pushing along this side, pushing along this side, then how much will be shear stress inside maximum, or how much will be the normal stress? What will be their direction? That we need to figure out. So how we can figure out that? What we see over here, that inside sigma will develop in this surface, but its value varies with phi. So for example, what does mean sigma del y by del x? Say this is a graph. Along this direction is x, this direction is y. Now straight line, what does the straight line, what does it mean? dy by dx equal to constant, m constant. M is not changing. But if it is a curve, then your graph might be go this way. What does it mean? It means that at one point, value of right over here, how much the slope? 0. Right over here, slope 0. And after that, slope increasing, from here to here, slope gradually decreasing. So that means at this point, slope is 0. What does it mean? Slope is 0 mean I can say dy by dx. That means right over here, value of dy by dx equal to 0. If slope 0, for that point, our y value is maximum. Over here, you see y value maximum slope is 0. If you know the value of x, that value you put in the equation, then you get the y value right over here. That how much this y value from here to here, and how much this y. Okay. Now you see this is our sigma equation, mother equation. So this equation only variable is phi. So I figure out the derivative. Del sigma by del phi. I say this equal to 0. Then from there we figure out the condition. So you derive respect to this one 0. This one is constant. So remain. I just simplify a little bit. And derivative of this one minus 2 sine 2 phi plus xy, tau xy. This one 2 cos 2 phi. This equal to 0. So this value equal to this value we are getting, but I simplify. And from there, we figure out the value of tan by applying sine by cos theta equal to tan. So we are getting this. And instead of phi, I put phi. Because at that angle, the value of sigma will be maximum. Okay? Sigma will be that we did over here. Now, what will be the value of shear stress at the same plane? So what is the mother stress formula? This is a mother stress formula, right? And this is our sigma. So from tan value, what are we getting? We are getting that at angle 2 phi p, sigma will be maximum. Say phi 2 phi p equal to 80 degree, got after calculation. Then right over here, you can put 2 theta equal to 80 degree, 2 theta equal to 80 degree. Similarly, in tau equation, you put 2 phi equal to 80 degree. Then you see equal to automatically result. But I like to figure out the value of sigma and sigma 1 analytically by using the mathematics. How can do it? So you see, this is my condition. This is my condition. That means I need to figure out value of sigma 1, sigma 2, where it is the maximum or minimum. But I know the angle. If the angle is 2 phi p, then sigma value will be maximum. So I need a formula. I don't like to put number that tan 2 phi p equal to 80 degree, then you put over 80. I want to a formula. There will be only sigma x, sigma y, and tau x. How we can do it? In that case, I need to take out the sine phi. This portion I need to take out. Only the sine phi portion. Then I need to take out cos phi portion. Similarly, in the tau formula right hand side, I need to take out take out this sin phi, and I need to take out this cos phi. How you can do it? You see, easily you can do it. Tan 2 phi equal to this much. From here, I need to figure out the value of sin 2 phi p and cos 2 phi. How you can do it? Say, for example, I am saying this is a triangle. Obviously, it's perpendicular, right? Say this is theta. This is theta. I am saying this is 3, this is 4, this is 5. So how we can figure out the value of sin theta cos theta? Just using sin theta, perpendicular by base, cos theta, base by hypotenuse, right? And sin theta equal to perpendicular by hypotenuse. That means 3 by 5. And cos theta will be 4 by 5. Now, right over here, value of tan is coming in terms of sine and sigma x, sigma y, and tau x. No cos phi is there, right? So how we can figure out the sine phi and cos phi? Easily you can figure out the way I draw the triangle. How? Sine theta equal to base by perpendicular. So perpendicular by base, right? Lombo by bhumi, Bangla. So tau xy is my perpendicular, and half sigma is my base. So what will be this length? Square of this one plus this one, square, then root over. We get plus minus this one, because since it's a root over, right? Now we have this length, we have base, we have perpendicular. We can figure out cos 2 phi. Cos 2 phi equal to base by hypotenuse, then sin 2 phi equal to perpendicular by hypotenuse. Right over here. Okay. So these two value I just write over here again. Now these two value I'll put in my mother equation. Right over here and right over here. Then I look that what is going on. What kind of formula I'm getting if I take out the sin phi and cos phi. So first we put value right over here. So this value remains the same. Right over remains same. This value remains same. So this will like to be like that. Now cos 2 phi equal to how much? You look at the formula. This is cos 2 phi. I took from here. So I put it cos 2 phi in the formula plus tau xy sin 2 phi. So this is tau xy. This is, and this is sin 2 phi from here to here. So sin 2 phi right over here. This is sin 2 phi. So you see, if you put there, then what you getting? This term and this term actually square. If this is x, that means x square. In the bottom, we are getting this one. So I put it like that: x square divided by denominator. And I similarly write over here tau x into tau xy whole square. And in the bottom, I am getting this one. Now you simplify. Then what is coming this one? This term, obviously it will be given as same like that, right? And this one is coming like at the top, we have like a square, right? Then in the bottom, we have x, right? Plus, we are getting b square divided by y. I'm sorry, a same value, x. So if you simplify it, what do you get? A square plus b square divided by x, right? So that one I did. This is my x, upper one is a square plus, this is my a square plus b square. Now what did you see? Then second simplification is coming like at the top we have x, and in the bottom we have root over x, right? You see, hold this value. If you think this is a, then bottom we have root over a. So after you cut, you will get this. So this is sigma equal to sigma x, sigma y by 2, and this is the plus minus. Plus minus should be, I was not able to put in the this way in this program. Normally you put plus minus sign, this is plus, immediately below minus, right? So you use one time plus sign, you'll get 1 sigma. You one time minus sign, you'll get 2 sigma. So what do you see? For same angle, you are getting 2 sigma. One is sigma 1, other one is sigma 2. That we already show you. But why you are getting that kind of value? There is a specific reason. I am saying, say tan. If you have calculator, you can figure out the value tan, say 20 degree. I'm not sure. I might be other. Say this one, 20 degree equal to this. Theta equal to 20 degree, right? And if I say tan, okay, and tan 200 degree equal to how much? Same value. So if I got, for example, I got tan theta equal to 0.364. What will be the value of theta? I can say theta equal to 20 degree, is also right, but I can say theta equal to 200, is also right. Why? Because tan 180 degree plus theta equal to how much? In trigonometry, tan theta. So from this formula, you will get a one angle. Say what 30 degree. Tan 2 theta p equal to 30 degree. Or it will be other angle. So you got, let me write down, you get 2 pi p, we have pi, say pi p equal to, you got 40 degree. Okay. So what will be the other one? 2 pi p, if I p substitution, other one will be 40 plus 8. That means 220. Okay. So that's why now you see you are getting two principal plane, not only one. One is 40 degree, other one 220 degree. This 40 degree and 220 degree, if you put in this equation, what do you get? You got a sigma. If you put in this equation, you will get tau. And obviously this tau will be 0. It's not coming 0, that means you are wrong. Again, you put 2 pi equal to 220 degree, you get sigma. And you put tau over here, obviously you get tau. So you need to figure out the both angle and both sigma. That means sigma 1 and sigma. And secondly, this formula also you can use. You will get sigma 1 and sigma 2. Now, what about the shear stress? I know that if theta equal to 20 degree, I got sigma maximum. I know, okay, but what is the shear stress here? Theoretically, we know, I told you it will be 0. But what is the proof? Mathematically, you can put that 20 degree. If that 20 degree, say I got tan 2 theta p equal to 20 degree equal to, you got say tan 2 phi p equal to 0.364. Then you can say theta equal to 2 phi p equal to 20 degree. That 20 degree, if you put over here, it will come automatically 0. But I don't want to see that. I like to know that you mathematically prove it. That is coming 0. So how we can prove it? What is our condition for principal plane? Tan 2 phi p equal to, this is our formula. And this is my equation. So from here, using this condition, I'll figure out the equation. That equation I'll put over here and see it is coming 0, 1. So you see tan 2 phi, it I divided sine theta by cos theta, then I got this. Okay. Then I just simplify the equation. What I getting? Sine this one into sine 2p equal to tau xy into cos phi. Now this value, I will put it over here. You see that there is a minus sign. So this value equal to minus tau xy cos 2 phi plus tau xy cos 2 phi. So automatically coming 0. You see minus tau xy cos 2 phi plus tau xy cos 2 phi equal. Now, what is the summary? Summary that we have one mother equation for principal stress sigma and one shear stress function. For principal angle, this is the angle. This angle, when you solve it, say 2 theta equal to 1. You got tan 2 theta p equal to 1. So what is the value you will get? Say for example, you get tan 2 pi pi. This equal to you got 1. What will the value of tan 2 phi then? 2 phi value, you can say 2 phi equal to 45 degree, right? Because tan 1 equal to 45, right? So I can say like this one, I can say equal to tan 45, right? Or I can say this equal to tan 100 into 45, 180 plus 45. I can say 180 plus 45. So 25 equal to, if somebody write down 45, he also write. If somebody write down 225, also write. Because both on giving you value 1. So you get two angle. These two angle, you put one time over here, you get sigma 1. One time over here, tau. Next time you put this one, you get sigma 1 value. And you put tau again, this angle in the tau equation, you get tau equal to. So for principal plane, shear stress always 0. Only remain two principal stress, sigma 1, sigma 2, and angle of principal plane 2 pi. Okay. So far, any question? Anyone? No question? Azmain?
Maybe no, sir.
No question? Okay, good. Now we'll try other equation. This one we did what? That for which value of phi, sigma will be maximum. Similarly, we need to figure out for which value of phi, tau will be maximum. So right here, what we derive? A derivative. We figure out that make derivative of mother equation of sigma. You see at the beginning, we figure out d sigma by d phi, right? Similarly, we'll figure out d tau by d phi. So let's see that equation right over here. Derivation for shear stress, maximum shear stress. Similarly, we can figure out. You see, this is my mother equation. So I'll figure out d tau by d phi. Then what will be happen? This remains same. Sine 2 phi p, 2 cos 2 phi. Over here, cos derivatives, the minus sign, tau xy into sine equal to 0. Now from there, this is the equation. You simplify, then you get tan phi 2s equal to this. This is the condition we got now. Tan 2 phi s equal to this function. So in that plane, your tau will be maximum. And shear stress, normal stress is not 0. There will be some value. So that we need to figure out. Now, how we can figure out? Number one thing you see, so I know I got two phi into S subscription. This one we know, I know. So in that angle, say for example, just for example, it was 70. So in that angle, how much will be the sigma? Sigma equal to what? Then we need to figure out how much will be the value of tau. So these two things we need to figure out. So this angle you put in the mother equation of sigma, mother equation of tau, you'll get it. Okay, but I like to do mathematical. How you can do it? So this is my formula. Tan 2 phi s equal to this one. You see in the mother equation right over here, mother equation one for sigma and one for tau, right? This is for tau. So right over here we have sine 2 phi cos 2 phi. Over here cos 2 phi sine 2 phi. We don't have that value, sine 2 phi cos 2 phi, but we have value of tan 2 phi. So by using a perpendicular triangle, we'll figure out the sine 2 phi and cos 2 phi value. That value we'll put in mother equation. Then we'll get equation of sigma and tau. So how we can put it? We say tan theta equal to perpendicular by base. So this is length, right? Half sigma x minus sigma y, tau xy. This is hypotenuse. From there, you figure out cos 2 phi and sine 2 phi. And you see there is a mistake. This will be S, not the P. This will be S, but this is my mistake. Okay. So you see, I write down at the bottom. This is my cos 2 phi. Yes. This is sine 2 phi. This angle we put in the mother equation. Then see what's going. For example, value of sine 2 phi cos 2 pi in equation 1. What is our equation 1? This one our equation. So in that equation, this is remain intact. Sine 2 pi value will be on the right side. So this is a value of sine 2 pi. How we got right over here, sine 2 pi. Then we have cos 2 phi. Cos 2 phi value is right over here. Right here, this cos 2 pi. So this value we put over here. And you look carefully. This is x, this is also x. So at the top will be x square. So you see first term coming this one. This one is coming like x square. In the second portion, tau xy, tau x square. In the bottom remains same. Right? So if you simplify, numerator is same, right? This value and this value is same. So if you simplify, you will get a numerator, then a plus b. This is my a, this is my b. So after simplifying, how do you get it? You're getting at the top x, in the bottom root over x. So you have plus minus root over x. So this is the tau max and tau minimum. Analytical value. And if you put directly the formula, you can easily figure out. Not formula, directly angle. Now, this is maximum tau. You use plus sign on tau, minus sign other tau. But you see, both tau is the same value, but one is maximum, that means plus sign, other one is minus sign. Okay. Now you see, we need to figure out what is the value of sigma in that plane. It might be 0, it might be negative. If you put angle, you can figure out. Say phi 2 phi p, you got 100 degree. You put right over here, you will get it. One will be 100, other one will be 100 plus 180. That means 300, 280, right? So you get sigma 1, sigma. But no, I like to get it mathematically. How we can do it. So I just use this condition that where is my sigma, I mean shear stress is maximum. What is that angle? This is the formula. Tan 2 phi s equal to this is the formula. So this one tan 2 phi is, I simplify, write down sin 2 phi by cos 2 phi. Okay. Then I simplify this equation right over here. I can say sin 2 phi is into tau xy equal to half this one into 2 cos phi is. And remember, here is a minus sign. That at front there is a minus sign. So after simplify, this minus sign you bring in the left side, it will be plus. So plus this one equal to 0. And look in your equation 3. You see this term and this term is the same. What does it mean? This value equal to 0. So this is 0. So our sigma is coming sigma x plus sigma y divided by 2. That means if you are adding two numbers divided by 2, that means you are taking average. If sigma x equal to 30 and sigma y is 60, what is the average? 90 divided by 2, 45. So you see, for example, you got 2 pi s. For example, you will get two value always, but 10. 2 pi s, one you got say 60 degree. So how to do the other one? 160 plus 180. So 240. If both angle, if we put in this equation, you will see this part is coming always 0. This part coming 0. Only you have this for both equations. Okay. So what is the summary? Right over here. Summary, at the maximum shear plane, principal stress is equal to average of sigma x, sigma y. And shear stress tau 1, tau 2. Both are equal and opposite. And principal plane is 2 pi s. So what is the formula? You see, this is mother formula. For shear angle, principal shear angle, this is the formula. And in that plane, if we use the shortcut, then you will get sigma equal to sigma average, and this is tau equal to tau max and tau minimum. Plus sign you will get one value, minus sign you will get other value. And you look in the principal plane, tan 2 phi, how you can figure out. This is the formula. And this condition, when you put right over here and right over here, you always get tau equal to 0. And sigma, you get this one, sigma x plus sigma y divided by 2 plus minus this one. So with plus you get one value, with minus you get other one. And you look carefully, the square root over this term and this term is same. That means sigma 1 equal to sigma x plus sigma y divided by 2 plus tau. This is actually the tau max and tau. Okay. So far, any question? Anyone? Anyone? Any question? Anyone? Are you there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Thank you. Okay. Sometimes you should give response. Otherwise, I might think that you are not here. So if I summarize all the formula, right over here, this is mother equation of sigma, mother equation of tau. What is the condition for principal plane? Right over here. So if you solve tan 2 phi p, say tan 2 phi p equal to, you are getting 0.05, for example, or 0.35. From the calculator, you get angle. Say angle you got 47. Tan 2 phi p equal to 47. What is the other angle? Tan 2 phi p 47 plus 108. So you get two values of tan 2 phi. That value you put in the equation sigma twice. So you get sigma 1, you get sigma 2. Then same value you put in the equation tau. You get tau 1, tau 2. But both cases you see tau 1, tau 2 is 0. But when you put the angle from the shear stress right over here to shear stress, you get angle. So one angle you got 60. What will be other one? Then 2 pi s equal to 60. Other one will be, so let me write down, then it will be, oh, here. Say 2 pi equal to, you got 60. So what will be other one? Other one,
Sir, 180 plus
you
60.
can say 2 pi 1 equal to 180 plus 60. That means 240. These two angles you put in the first equation. You will see this value, you have only this value, a right side value coming 0. Is not coming 0, then you're wrong. Sometimes you make mistake. So you got the sigma. What will be the tau? These two angles you put in this equation. In this, it is the value of tau. And that tau will be equal to same as this value. Is not coming same, you are making mistake. And similarly, when you use this one, you get sigma 1, sigma 2. Then you can cross check with this one, sigma 1 and sigma 2. If it's not same, you did somewhere mistake. Similarly, tau will be 0. It's not coming 0, that means you make mistake. Now, my question, which one you will use? You see, if you use this one, directly you know the sigma 1, sigma 2. And theoretically tau equal to 0, right? But you are not able to tell me the angle. That what is the angle to 5p? Is it 10 degree or 40 degree? So that is the one issue. Similarly, if you use directly this equation, you cannot say what is the angle to phi s equal to how much. So I feel it is better that you first figure out this angle to phi s and to phi. You figure out the two angles. That two angle you put in the mother equation. Then you get the sigma and the tau. Okay. So our class will be until 2:40, right?
Yes, sir.
Yes, sir.
240.
And how long time we have?
Sir, more 40 minutes.
More than 40 minutes. Okay. So what I can do, I feel that your brain might be overloaded a little bit right now. So we can put you on break, 5-minute break. Okay.
Okay, sir.
Then come back at 2:03. Okay. Hello, are you back?
Yes, sir.
Okay. So
Sir.
I think we can start it.
Sir,
Yes.
sir, today we had classes from 11:20 a.m. and we don't have any break. Sir, if you finish the class earlier, it will be beneficial for us because we have a quiz from 3:30.
What are you saying? You have?
Sir, actually we had a class from 11:20 and we don't have any break. So, and we also have a quiz from 3:30. So, sir, if you finish the class earlier, it will beneficial for us.
Yeah, 2:30, my class until 2:40, right? So why you take
3:30.
quiz at 2:30? You should deny it. You should say I have
No, sir, 3:30.
3:30. Okay, then it's okay. I'll try. Actually, we are behind, but I'll try to. Uh, there is one problem that I have to keep parallel with other section, Then otherwise one section behind, that is bad. But I will try to keep as short as possible. Then is problem that you might miss something. You see, sometimes I repeat again and again. I like to make sure that you understand it. But it's possible. In 1 hour class, material I can finish with like 30 minutes or 35 minutes. It's possible. Okay. But I'll try. Okay. Anyway.
Okay, thank you, sir.
Share the screen with you. Okay. Why is not coming in slideshow? This one second. not going in slide mode. Okay, now we can see. So what happened? These are the formula. I already put it over here. Okay. There is a something rule in this formula. You need to remember. One thing is that the sign of sin x, sigma x, and sigma y. Number one thing, sigma x, sigma y, if they are tension, if they are under tension, then it will be positive. What means under tension? Say, for example, right over here, sigma x working upward, sigma y downward, that is tension. But if I give sigma y along this direction, then sigma y will be negative. Similarly, if sigma x I give this way, then sigma x will be negative. Okay? This is one thing. Other thing about the shear. You see, shear stress we put along this direction when you derive the formula, right? That means this shear stress try to rotate the body anti-clockwise. So you will look right over here. We'll give you like rectangular element. We're not giving you this free body. Even give you the free body, you look that is rotating clockwise or anti-clockwise. Like this tau, try to rotate this body anti-clockwise. That means this is positive. So E tau positive for anti-clockwise rotation for this formula. And phi, you see phi, we count anti-clockwise. This is phi, so this angle also phi. That means this angle means you count from the x-axis, it is the same thing. From the x-axis, you rotate anti-clockwise, then phi will be positive. So those things you need to remember. Now, we derive, how many formula we derive? We derive formula at first, mother formula we derive. This one and this one. I just summarizing it. Making summation of force along x-axis equal to 0, y-axis equal to 0. Then we got two equations, one for tau, one for sigma. Then you solve two equations, multiply by cos phi sin phi, then you figure out the value of sigma and tau. This is the mother equation. Then we figure out what is the value of phi for maximum value of sigma. So how do we do it? We make derivative this equation. That means we figure out d sigma, my mouse pad is bad. We figure out d sigma by d phi equal to 0. We try to figure out the condition, then we got this. Similarly, we figure out derivative d tau, that for which value of phi tau will be maximum, and we got this. And when these two conditions, this condition we apply in the mother equation, then we got this. Okay, this formula you need to remember. Now, the way we derive, it look like we are solving math class. That's why this process is called algebraic method. Okay, this is called algebraic method. So let's see, if we solve a problem, then it will be clear to you. There's a two problem I put. Because in this problem, you look, as per sign convention, there is no sigma y. So what is the value of sigma y? That means sigma y is there, but no value. That means in that case, sigma y equal to 0. Sigma x equal to 8. Tau xy 50. But which direction is rotating? Clockwise. So you put tau xy equal to minus 50. And right over here, I already said tau xy minus 50, sigma x equal to 8. And you might say, what is the sigma y? It's not showing. So sigma y will be right here 0. But if I put sign like that, I say 100. What does it mean? That means sigma y will be minus 100 in that case. In that case, you have to put sigma y equal to minus 100 megapascal. Okay. And in that case, tau xy will be equal to minus 50. And sigma x equal to will be right over here will be 8. So this way you figure out before you start your math. Now we will solve problem 2. Number 1 we will not solve it. If we solve problem 2, you can solve it. Okay. This is a plane stress element is given. Now you need to figure out the principal and maximum shear stress. That means sigma 1, sigma 2, tau 1, tau 2. You need to figure out their direction, that means angle, by using more circle diagram than this will be it. Okay. But you need to figure out by algebraic method. Okay. So how we can do it. So let's solve the problem. We can solve it by over here. Window. This is problem 2. Okay. So in problem 2, you see it's a find principal and maximum shear stress and their direction by algebraic approach. And it's a also by using more circle diagram. That is different thing. We'll discuss it later on. And it's a figure out the alignment or direction of each element respect to xy coordinate. Okay. So this is our plane stress element. You immediately you have question, then you need to realize that I have to use this mother equation. So I write down over here. Or you need to use this the direct equation. This with plus minus you will get sigma 1, sigma 2, tau 1, tau 2 by using plus minus. But if you directly use this equation, you will not get angle. You need to figure out the angle. Okay. So I mention it again, it's better to start with mother equation. So what is our principal plane formula? This is our principal plane formula. What is our shear stress angle formula? This one. So this one I just put it to make sure that you understand it. Okay. Now then you say given. What value are given over here? So you see if I bring this element, if I select this one, copy it right over here, copy it right over here. So what do you see? Sigma x, how much? 90. You see sigma x equal to 90 megapascal. Because it's tension positive. Sigma y also tension, so it will be 30. But if this sigma y I give in opposite direction, then it will be negative. Okay, that's negative. And tau xy. And now you see tau, this tau, try to rotate this body clockwise direction. That means tau xy negative. So I could write over here tau xy equal to minus 40 megapascal. Now we need to figure out the tan 2 phi p equal to this our formula. Right over here. So in the calculator, you put the value. Tau xy value, sigma x, sigma y, you get tan 2 phi equal to how much? Directly you get the value. That value will come minus 1 point. I did over here in different way, but by using calculator, you can easily figure out. So by solving that, I got 2 phi equal to minus 53.13. So what will be the other angle? You directly add 108. So 2 phi p equal to 53 point minus 53.13. And other angle is minus 53.13 plus 18. So I'm getting 126, and right over here I'm getting minus 53.13. So 2 phi angle. These two angle, if I put right over here, twice I get sigma 1, sigma 2. I put over here, I get tau 1, tau. Very simple. So if you put in these two equation, I did one thing over here. I got 2 phi value. Then from there, I can say right over here, instead not only 2 phi 1, right? I can say it's 2 phi 1 and this one is 2 phi, 2 different angles. Then from here, you can figure out phi 1 instead of 2 phi. But I put this one because in the equation you have first 2 phi. That's why. Okay, now these two value you put in the mother equation. This mother equation. Then sigma 1 you will get 200, 110. When you put this 53.13 or phi equal to 26.57 degree. You put second one how much? Phi 1 equal to 63.43 or 2 phi equal to 126.87. When you put that angle, you got 100. So sigma 1, 110, other one, 100. Now you see tau 1, tau 2, when you put the value, both is coming 0. That means your result is right. So this is your result. When phi 1 equal to minus 26 degree, then sigma 1 equal to this much. Tau 1, 0. When angle is this much, sigma 2, 10, and sigma 1 equal to, tau 2 equal to 0. This is your result. Now, this result, you need to put graphically, represent graphically. How you can put it? That is called orientation of the element or direction of the element. Very simple. Okay, this is my result. I like to draw the orientation of the element in the right hand side. So how we can draw it? At first, you draw our original x-axis. So our original x-axis was horizontal, right? Now at first you start with smaller angle. Which is smaller angle? Phi 1. If it's phi 2, you can start with the phi. Better to start with the smaller angle. So this one minus 26.57. You remember, in algebraic method, anti-clockwise angle is positive and clockwise angle is negative. So minus 26.57, that means we need to go clockwise direction. How much? So this is my x-axis. So I am putting x over here. Okay, my mouse pad is bad. This is x-axis. Okay. So if this is x, then x, original x. Now, with this x-axis, this is the origin. I need to draw this angle, but minus. So I need to go clockwise direction. So this will be, if this rotate clockwise direction, this is my angle. Then I put this is, and just I mention it that this angle is 26.57. You just mention. Okay. So I'm not mentioning it right away. The space is limited. Also, mouse is not working. But I'll show you how we can mention. Okay. Now what we'll do? Remember this angle 26.57. Now I will draw the element. How I will draw the element? I forget about this x-axis. I just make sure this is my x-axis. This is my rotation. Now with this rotation, I will make the square, that plane stress element. And exam, in the exam you will use scale and pencil. Make sure this line about at least at the center of the tip. Okay, so this is my rotational element. Now in that element, you'll make sure this angle is 90 degree. That means this line and this line is perpendicular to each other. Now, when you rotate by minus 26.57, what is the sigma 1? Sigma 1 is 110, right? So sigma 1, right over here, you got over here, you got over here, right here, it will be 110. So you just write down. Say this is my 110. You put the unit 110 megapascal. Then you say this is sigma 1. Okay. Now this phase, there will be tau 2, but tau coming -0. That means tau actually 0. So you can avoid or you can put arrow. So I am putting arrow. But this value is 0. Now what about this side? This side you got 110 sigma 1. So obviously this over here has to be 110. So over here you say right over here sigma 1 equal to 110 megapascal. Then you put sigma 2. So where will be sigma 2? Sigma 2 equal to 10. So one side you already have the number. So sigma 2 should be this two side. And this is positive. There is no negative sign. If negative sign, arrow will be to the object. Because it's positive sign, arrow will go from the object. So this 2 is my sigma 2. Now we just write down that sigma 2 equal to 10 megapascal. Okay, you write down this is 10 megapascal. Similarly, over here you write down sigma 2 equal to 10 megapascal. Now, you need to show the shear stress. You show one side. Right over here, shear stress all 0. If you like to show them, then say tau equal to 0. But if you put in the one side, that will be wrong. So shear stress always head to head and tail to tail. Then this will be other one will be right direction. Then you just mention the number, what is the tau. Then you say tau equal to 0. Over here you say tau equal to 0. So this is your orientation of the element. That we did right over here. But I didn't put the direction of the shear stress. I can put any direction. Remember head to head and tail to tail. So this will be tail to tail. Other one will be other. Okay. And in the orientation of principal plane. And I don't write down sigma 1, but it's better you write down sigma 1 equal to 110 megapascal. Then you write down sigma 2 equal to 10 megapascal. Okay. Then this is you got the principal plane. Now what is left? Your shear plane you need to figure out. So what is my shear plane formula? This is the angle. Then 2 phi s equal to this one. So after you put all the number, then you will get tan 2 phi equal to this value. Tan 2 phi. I don't put it the what value I got. I got y1, right? Y1 value. I can put it over here y1, but I can say y dot 1 equal to how much? Is not this value is not given. Okay, but I figure out from here. You see y1 is right over here. I think I can figure out y1. See, let's see. It shows me giving me the y1. Okay, 0.75. That means tan 2 phi s. I got tan 2 phi s equal to I got 0.75. Now I figure out phi s. So phi x equal to 37.1 phi s. So we are getting 2 phi s1 is equal to 36.87. So what will be the other one? 2 pi dot s 2 is equal to 180 plus 137. So I'll get 1 is 6.87. Now these two angles we put in the mother equation. That means our tau 1 and tau 2 equation, we get the value right over here. Twice you need to put. So if we put there, right over here. So this is my tan 2 phi 1. Then I got phi 1 and phi. This is our mother equation, tan equation. We put there, one time we got minus 50. And if you put the second angle, we got this 50 plus 50. Tau 1, tau 2 is same, but one positive, other one negative sign. And what is the sigma 1, sigma 2? You put that formula, you got sigma 1, sigma 2. You see both angle you put, you got 160, only 60. Why? Our sigma x equal to 90 and sigma y 30. Look in the right over here. Sigma x 90, sigma y 30. 90 plus 30, 120 divided by 60. So both cases, you see yeah, both cases we got sigma 1 60. Okay, tau 1 when you put 18 degree, tau 1 minus 50. When you put 108, tau 2 plus 50. Now, how you will do the orientation of the image? So similarly, we start first our original x-axis. So what is our original x-axis? Is going along this direction. This is our original x-axis, and I'm saying this is x. Then we look for a smaller angle. Which one is smaller? Phi 1 is smaller. How much? 18.43. It's positive. We know algebraic method. If you rotate anti-clockwise, it's positive. That means you draw this angle. So this is the angle. 18 point something. Then you show the angle. And you write down over here with your pencil or whatever the pen. You show that this angle is 18.43 degree. We'll mention. Okay. So I just erase it that one. Now, you forget about this axis. Now our new x-axis is this one after question. So with this one, you need to make a cube. So you make 90 degree line. Make sure that this vertex will be at the center. So I'm just making like that, making like that, then like that. Okay. Now, when rotate anti-clockwise, and remember, when you're making anti-clockwise, you just put a show it with anti-clockwise. Then what is the tau you are getting right over here? Minus 50. So tau, when rotate anti-clockwise positive, but this tau rotating is minus, it will rotate clockwise. So tau in this side will be along this direction. Okay. And right over here, how much the value of sigma? 60. And it says positive 60. If it's minus 60, then the arrow will be to the object. Positive 60. So this is my tau. Right? So what will be no, this is sigma. So what will be sigma over here? Obviously same. And you see other one, sigma also 60 and positive. So this will be 60, this will be 60. Now, I will draw the shear stress for all other 3 A's. You can just close your eye and make it tail to tail, head to head. You already fixed this one. So other one will be along this direction and tail to tail. So from the tail you make head and one head will go right over here. Now you just mention that this is the tau equal to 50 megapascal. Not 50, 60 megapascal. And then you say this is sigma average. You can say sigma average equal to, we got 60. This one you say sigma average 60. Right over here you say 60. Right over here you say 60. Then you say this is a picture for shear plane element or shear principal shear stress. You see, it's a orientation of shear plane. So you see sigma bar is equal to 60. This is tau. I put over here. I put over here. So this orientation of shear element. So this is your result. Now this result you can check it with this number right over here with the other shortcut formula. With this formula, you check it, you will see you will get the sample. Okay. So anyone has any question? Any question? Hello? Are you there? No question?
Yes, sir. No,
Okay,
sir.
good. Then I just take 1 more minute to keep you parallel with other section. Then we'll close it. Okay. The way I show you to solve the math, that one is called algebraic method. But there's a second method we use that is called graphical method or is called Moore circle method because scientist Moore, he developed this method. You have the same problem. With that problem, if you draw a circle, from that circle, you can figure out your sigma 1, sigma 2, tau 1, tau 2, and all the angle without applying any formula. Okay, the most simple one. So I say this is a circle. So to draw a circle, what do you need? To draw a circle, you need the center of the circle location, right? Then you need a radius. What is the radius? If you know the radius and center, you can draw the circle. Then in the circle, if you draw somewhere, you need a scale, x-axis, y-axis, right? So in plane stress formula, if you draw something by Moore circle, at first you need to figure out the center. So location of the center will be this one. Sigma x plus sigma y by 2, comma 0. So this will be along x-axis, this will be along y-axis. And this will be the radius. Okay. So we'll just 1 second. Hello. Alaikum salam. আচ্ছা একটু ক্লাসে আছে তো একটু 1 মিনিট পর একটু ফোন দিতেছি আপনাকে আচ্ছা 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 okay so this is the radius of the circle and this is the location of the center and how we draw the circle we will make a x-axis y-axis we will make this is y-axis we make this is instead of x along x-axis we will put sigma. If sigma positive will be along this direction, if sigma negative will go along this direction. And vertical direction will put tau, positive tau, and in y negative y direction we'll put negative tau. And we'll start it from here from on Saturday, tomorrow. Okay, not tomorrow, day after tomorrow. Tomorrow is the Friday. So any question? No question? So we can keep it here.
Yes, sir.
Yes, sir.
Okay. So
Sir, we
thank
have
you.
extra
Thank you,
class at
class.
Saturday.
How to say? Saturday 9:30. You will be two slot extra class.
Sir, 10:30, sir.
Somebody request 9:30. If it's 2 hours, 10:30 plus it will be until go 12:30. So tell me which one you want? 10:30
Sir, 10:30. Yes, sir. 10:30.
or 10 o'clock? What about 10 o'clock?
So 10 o'clock will be
10
convenient.
o'clock will be better because you have Zoma pray, you know. So 10 o'clock, then 10 to slot before 12. Okay, so thank you.